We've looked at some of the drive types already. Let's take another look at some of these, and we'll add a little bit of information about them. We have here in this slide that some of the most common types of disk interfaces are the SATA, the SAS, and the SCSI. However, we really don't see the SCSI very much anymore, and we have a couple of things left out here. Prior to SATA, we actually had another type just called the ATA, or sometimes called the PATA. Now, PATA actually was not the original name of it. That name was made up after we started using SATA, which was serial ATA. We started out calling it the ATA, and then once we came up with the serial ATA, then later on we said, well, the old version was parallel, and so we'll just call it the parallel ATA. We also called these, by the way, IDE. So ATA, PATA, and IDE were all the same. And by the way, there was an enhanced version, EIDE. If you see any of these names, ATA, PATA, IDE, EIDE, think of them as all essentially the same thing, the predecessor of the serial ATA. These are advanced technology attachments. So these are the parallel and the serial versions of those. Now, next we came up, actually, the next one came along that was SCSI, and SCSI is Small Computer Serial Interface, and that actually has some limitations and is really no longer popular. So we don't use SCSI very much anymore, but we have a serial attached SCSI. So I guess if I were to put a number on these things and put them in order, I would say that these were the first, and then these were the over here. This would be the second ones that we saw. This would be the third technology that was popular, and then the fourth technology that was popular would be the SAS, or serial attached SCSI. And now we have kind of a fifth one that is has become popular, the NVMe. So the NVMe we'll talk about in another slide in just a few moments. So if you can remember these five, you'll be doing pretty good. But again, we really no longer use these. We no longer very often see the old ATAs. We no longer really see SCSI. We do see SATA drives, and both solid state and magnetic drives are very commonly SATA drives. SAS drives are they're very common in servers, and in fact particularly common where you have a whole mass of drives lined up in a server that you can remove and put back in. We call them hot swappable. You can take a drive out and put another drive in its place while the server's running. And we'll see an interesting idea about that again on the next slide. And then the NVMe we'll see on a future slide in just a few moments. I said that there was, let me get rid of this other stuff here. Serial ATA drives. I said that there was an interesting thing coming up, and I guess it's on the next slide, so hold on to your seats for that one. So the serial ATA drives have replaced the old ATA or PATA drives. They are faster. They have smaller cables. Serial ATA drives are inexpensive, fast, and reliable. Yeah, that's a good characterization of them. Here's the one I was very interested in. The fact that SATA drives can be connected to SAS backplanes. So it turns out that the SAS backplane is a card that is attached to the motherboard and usually allows multiple drives to be plugged into slots in the computer. Well, it turns out that these have more pins than SATA drives have. However, you can plug a SATA drive into them. It just ignores those extra pin slots. However, you can't do it backwards. You cannot plug a SAS drive into a SATA drive slot because the SAS has more pins, and so you can't fit it in there. But you can take a SATA drive and plug it into a SAS backplane. So that backplane is that separate card, we call them a riser card, that comes off of the motherboard and allows you to plug in these extra drives. Now the NVMe. The NVMe, non-volatile memory express card, is just a storage that plugs into the PCIe bus directly. In other words, the slots on the motherboard, it plugs directly into those slots rather than having a cable that goes to the motherboard and then setting the drive setting off to the side. This drive plugs directly into the slots that are on the motherboard. Now, I said that the SAS drive has an extra board that plugs into these slots, and then we plug the drives into that board. But in this case, the drive plugs directly into the slot on the board, so you don't have to have an extra board sticking out of the motherboard. So we call those the NVMe, or non-volatile memory express. Now, when it comes to partitioning drives, we have an older method and a newer method, and you can ignore this information here. It says that the master boot record, which is the older version, is the most common method. That is no longer true. This slide is a little bit outdated. The master boot record method was around, as it says here, since DOS. This is based on the old BIOS chip. Now the BIOS chip, and let me write this on here. This is based on the BIOS chip. The BIOS chip is a chip that's on the motherboard that knows what hardware is in the computer, so that put a new drive in or some new hardware on the computer, you have to configure that in the BIOS chip. But it was somewhat limited, and it was all done in command line. Today we have a more expandable and graphical type of chip called the UEFI chip. By the way, the BIOS chip had to have a battery backup in order to keep it alive. The UEFI chip uses a flash memory so that it is not non-volatile and doesn't have to have that battery backup. Notice that only 2 terabytes can be supported with the old MBR style of partitioning, where with the UEFI you can get up to 9.5 zettabytes. Now, what in the world is a zettabyte and what in the world is a terabyte? Well, I've put an extra slide in here that's not in the original set of slides with that terminology. So here are the gigabytes you're familiar with. You may be familiar with terabytes in larger hard drives today. This is about where we are today in our hard drive technology. After this would be petabytes, exabytes, and zettabytes. I always remember those by thinking about the candy Pez, P-E-Z. So remember after terabytes, so petabytes, exabytes, zettabytes. After that would be yottabytes, brontobytes, and geobytes. By the way, the P is silent and it's pronounced geobytes. However, if you were to put together all the data on the internet today, we're only in the, as far as I know, last in the exabyte range. So it'll be a while. We might be up in the zettabyte range now, but we haven't gone beyond that as far as I know. All right. That's it for our drive connection terminology.